Let's say I'm importing some wine. I place an order, it's confirmed, and the shipment arrives. But as soon as I open it, I see it's full of reds when I ordered whites. My supplier says I did order reds, I say I ordered whites, and we argue back and forth about what happened. Now the problem here is trust. Our records are clearly out of sync, but as neither of us trusts that the other's records are correct, it's quite hard to reconcile them. The other problem is the fact that we're keeping them separately in the first place, because unless we make a point of syncing them up, there's always a chance they're going to diverge. So this begs the question, how do we keep them in sync? Traditionally, we nominate one party as the chief record keeper. But the issue with this is that you need to trust them. First to keep the records current and up to date, but also that they're honest and they're not going to change anything. This is not the kind of trust that comes overnight, and that is where blockchain comes in. Instead of everyone having separate ledgers or having one person in charge, blockchain allows everyone to collectively maintain a single shared ledger that's guaranteed to be up to date and genuine. So how does blockchain actually achieve that? Well, when we say blockchain, what we actually mean is a distributed ledger, and that's a type of database that's shared by multiple people. And they usually consist of three major components, which are the blockchain, the consensus mechanism, and the smart contract runtime. Let's start with the blockchain itself. A blockchain is a sequence of records, ordered by time, where each record is some kind of change to the database. We call an individual record a transaction, and we group transactions together in batches that we call blocks. Along with their transactions, each block contains a cryptographic link to the block before it, and these are the chains. You update the database by appending new blocks to the end of the blockchain, but there's a catch. Once you've added a block, you can't change it or remove it. So if you need to undo or change something that's been added, you actually need to add a new block with a new transaction that negates the effects of an old one. In truth, the blockchain isn't the database per se, but rather it's a history of everything that's happened to the database, and more importantly, it's a secure history that can't be changed. Why not? It's those links between each block, which are better known as the hashes. A hash is a function which takes in some data and outputs what can be thought of as the unique fingerprint of that data. And in blockchain, we use these hashes rather like a tamper-proof seal for the blocks. Each block has a hash, which is the unique fingerprint of all of its transactions along with the last block's hash. So if we want to check a block, we take these and input them into the hash function again. And if we get the same fingerprint that's on the block, we know the block's valid and hasn't been tampered with. But say it had been. Now when we run the hash function again, it'll have different inputs. And because hashes are unique to their input data, the fingerprints won't match anymore, which makes it clear that something wrong with this block. But wait a minute, why don't we just change the block's hash too? Wouldn't that make it valid? Well, it would, but that doesn't make it a valid block in our chain. The chain part of blockchain comes from the fact that each block's hash is used to make the next block's hash. And this creates dependency, where each block needs the last block to have a certain hash for its own to be valid. Or in other words, each block needs the last block to have certain transactions, and a certain block before it with a certain hash, which in turn needs the same thing, and so on and so forth. So what about this dodgy block of ours? Well, our chain has 4 blocks in it, and our block claims that it's the 3rd block in this sequence. If that's actually true, its hash would have been used in making the 4th block's hash. We already know what the 4th block's hash looks like, so we should be able to get it again by using our block's hash. But as you can see, we can't. So while this block might be valid in some blockchain, it's definitely not valid in ours. Of course, by themselves, the hashes won't stop anything. We could just recalculate the hashes and go all the way to the end of the chain if necessary. What really stops you is the fact that you have to sync up with everyone else. You see, the single shared ledger you collectively maintain is a logical ledger, not a physical one. In reality, every member of the network maintains their own replica of the blockchain, and whenever they append a new block, they broadcast this to the rest of the network, so everyone's kept in sync. So if you had changed something and sent out a new block, its transactions would refer to blocks that don't exist, or do exist but have different hashes to your own, and in much the same way, if you received a new block, then it wouldn't match anything on your own chain. What's in charge of this synchronization is the consensus mechanism. There are many approaches to this, but by and large the result's the same. Everyone has the same blocks, in the same order, containing valid transactions. So between the blockchain and the consensus mechanism, we can be sure that everyone has the same transactions. But what kind of changes do they describe? Every database powers some kind of app. But traditionally, we keep the two separate. There's a divide between the code and the data. But when it comes to blockchains, the code lives inside the blockchain along with the data. We call these applications smart contracts, and each transaction describes smart contract code running and changing something in the database. So we might have one transaction describing a contract adding an invoice for a wine order, and perhaps another contract which writes a confirmation of that order. So with all this in mind, let's say I'm importing some wine. I place an order on the blockchain and that's synced to my supplier's replica. They add a confirmation which is synced back to mine. We've also added the courier to the network, who adds their own updates when the package is picked up and dropped off. So what did blockchain give us? Because of the hashes in the consensus mechanism, I know everyone has the same view and there's no divergence. And because each transaction is a smart contract call, I have a full audit trail, showing me exactly how my order was processed and when. So if we don't trust in each other, we can at least trust in blockchain. Until I open the box, of course, and realise I've been sent reds again.